Hi girls. As promised, I'm not here today, so I'm going to make this little video for you to look at section 1.2, part 2. So we're still working with linear functions, but today, instead of supply and demand, we're going to look at cost, revenue, and profit. So again, more business functions using linear equations. So this is just a repeat of the slide from last class, just to show you that we have now taken care of supply and demand. And today we're going to look at cost analysis and break-even analysis, which is revenue and profit. Okay, so first let's look at cost. So again, when we're talking about cost, we're not talking about the cost a consumer pays. We're talking about the cost the supplier has to incur to make the product. Okay, so how much it costs to make the product. So the cost of manufacturing an item commonly consists of two parts. First is the fixed cost, and that's the cost for designing the product, setting up the factory, training the workers, etc. So it is the cost that you have to incur no matter how many products you're going to make. So whether you're going to make like 100 cupcakes or 2 cupcakes, you have to have an oven, for instance. So an oven would be fixed cost. Whether you're going to make 1 car or 1,000,000 cars, you have to have the factory, the machinery, the workers, etc. So for the most part, fixed cost is constant. It does not change, again, as no matter how many items you make. Marginal cost is the cost of making each item. So this includes like the ingredients for a cupcake, the materials or parts for a car, the hourly wages for the workers making the product, shipping, etc. So the marginal cost depends on the number of items made, number of items produced. So we can use, so as we said, we're dealing with linear equations, so we're going to use an mx plus b format for our cost. So this is our cost equation, again using x. And when we want to match marginal and fixed cost to this equation, and hopefully you guys can kind of guess this, the m represents the marginal cost, because again, m gets multiplied by x, so for every product we make, which would be our x values, we have to multiply it by how much it costs to make that product. So that's our marginal cost. The constant of b, or the y-intercept, represents our fixed cost. Because again, that doesn't change no matter how many items you make. Your fixed cost is just the initial output to start the process. Okay? So, a couple examples of problems here. So write the cost function. So again, there's various ways that you will be asked to write a cost function. Sometimes you'll be given certain values, sometimes you might be given points. So again, it's just like creating or writing linear equations. You have to look at the possibilities of what you're given, combination of information. So for instance, a company has an initial setup cost of $500. Each item produced costs an additional $15 per item. What is the total cost function? So again, we're going to be writing a cost function using mx plus b, right? Mx plus b. So again, the initial setup cost of $500. So that is just no matter what, it costs them $500 to set up. So that is going to be our fixed cost. So that's our B. Each item produced costs an additional $15. So however many items we produce, which would be X, has to be multiplied by 15. So that's a simple example. So our cost function is 15X plus 500, where X represents the items made, right? And then the answer cost will be how much it costs to make those items. So how much will it cost the company to produce 15 items? So we want to find C of 15, right? The cost for 15 items. So again, we're just going to plug in 15 for X. So 15 times 15 plus 500. And that should give us 725. So it costs $725 to produce 15 items. How much will it be to produce 130 items? Again, now we're just looking for C of 130. That's where the function notation comes in really handy. So C of 130 is going to be 15 times 130 plus 500. And if you plug that in your calculator, we get $2,450. Okay? So again, that's a simple example of a cost function where you're told what the fixed price is and you're told what the marginal cost is, and you just plug them in. Okay? Similar to writing a linear equation where you're given slope and y-intercept, right? But we also know it gets harder than that. So next example, so write the cost function. The marginal cost to make X batches of prescription medication is $10 per batch. So again, we're told the marginal cost is $10 per batch. So we know, again, that our M is going to be 10, right? The cost, this should be to produce, the cost to produce 100 batches is $1,500. So again, this is not giving us our fixed cost. Even though we're given our marginal, this is giving us a scenario of 100 batches is $1,500. So actually, that's giving us a point. When X is 100, the cost is $1,500. So now we're given our M and a point, so we're going to, again, solve for B. So again, all of these scenarios are what you've used before, you just haven't called them cost anymore, you just call them linear functions. So again, to solve for that, we're going to plug that in. So that we've got an X and a Y, right? So we're going to say 1,500 equals M, which is 10, times X, which is 100, plus B. We get 1,500 equals 1,000 plus B, and we get B equals 500, right, by subtracting. So our cost function, now we know our M is 10, X plus our B is 500. So we have our cost function for prescription medication. Okay, so now we can answer questions using that. So how much will it cost the company to produce 32 items? Again, we're going to plug in 23. We're going to plug in 23 into our cost function. So C of 23. So we get 10 times 23 plus 500 gives us what? 230 plus 500 gives us $730. To produce 530 items. Again, now we just want C of 530. So we get 10 times 530 plus 500. So 5,300, right, plus 500 equals $5,800. Okay, so again, another scenario for cost function is when you're given maybe the marginal cost and a data point. So again, same as when you're given slope and a point on a regular linear function. Okay, now there may be, back to cost a little bit, now there may be parts, maybe in your homework even, where on cost function, instead of being given marginal cost and a point, maybe you'll be given 2 points. And again, if that happens, you solve for it just like you would any linear function where you're given 2 points. You find your slope and then your B. Okay, so you just kind of have to keep an open mind about what you're given to create a linear function. Okay, so next piece of this lesson is revenue and profit. So again, so cost is how much it costs a manufacturer to manufacture items, right? But revenue is the amount of money brought in by selling a product. Okay, so it's just like if we go back to our homemade ice cream pie kitchen, it's how much money they get from selling cupcakes. So to figure out how much money you get from for revenue, again, the formula for that is really just how many you sell, so the quantity you sold times the price you sold them for, right? So that doesn't, we're not thinking about cost right now. We're just saying if I have 100 cupcakes, I sell them for $5 a piece, I bring in $500, right? And the revenue equation is noted as R of X, or sometimes R of Q for quantity. But R of X is always going to be equal to little p, which is your price, times your quantity, times your Q. Or actually, let me backtrack on that a little bit. If we're using X, it would be P times X. But again, in this chapter, they often use Q for quantity, so it'll be P times Q. Okay, so P always stands for price, X or Q stands for quantity. Okay? Now, so the company can break even when the amount of money they bring in from selling something, right, equals the amount of money it costs them to make it, right? So if your cost to make those cupcakes was $500 and you were able to bring in $500 by selling them, then you broke even, right? Your cost, you didn't make any money, but your revenue equals your cost, so you didn't lose any money either, right? So break even is when R of Q, so the revenue you brought in by selling the quantity, is equal to C of Q. So when how much money you brought in equals how much it cost you to make it. Okay? So you think, okay, well, that's great to break even, but I want to do more than break even, right? So as revenue continues to increase above the cost, so again, think about as you sell more, after you broke even, as you continue to sell cupcakes, over and above how much it costs you to make those cupcakes, then you will make a profit, right? So yay, we all want to make a profit. So profit is the amount of money actually made by selling the product. So the money you actually get to keep because you've already taken care of your expenses. So we can think of this in terms of just regular language. We can say the money made, or the revenue, minus the money spent to produce, which is our cost. Okay? So if we put that in math terms, again, it is this equation. So our profit, and again, profit and price, it's just the case of the letter. So profit is capital P, price is little p. So the profit of a company is the revenue, so how much money it brings in, minus the cost, or how much money it had to spend to produce a product. Okay, now you will be responsible for memorizing these relationships and these equations, but hopefully you can think about them in real terms and they just kind of make sense, right? So, and we'll be using them quite a bit before you have to actually memorize them. Okay, so let's look at a big example here. So revenue and profit for poultry feed. So a fascinating topic. So a firm sells poultry feed that the total cost in dollars is given by C of X equals 20X plus 10. So we're given the cost function. We don't have to write it out like we did earlier. They give it to us. So we've got marginal cost of 20, fixed cost of 100, all in a nice equation. So management plans to charge $24 per unit for the food. So this $24 actually represents price. So they're charging $24, so that's little p, okay? What is the revenue function? So again, remember, revenue is price times quantity, which again, quantity can be R or X, X or Q. So our revenue function, how much money we bring in is going to be our price, which is $24, times however much we make. So just 24x, right? If we're selling poultry feed for 24 per unit, we take however many units we sell and multiply it by 24, that's how much money we have, right? Okay, so now it says how many units must be sold to break even. Well, if you look back at break even happens when your revenue equals your cost. We were given we made a revenue equation, and we already had the cost equation. So our break even is going to be revenue equals cost. So we're going to say 24x when it equals 20x plus 100 That's going to be our break-even quantity. So now we solve for x. So we subtract 20x. We get 4x equals 100. Sorry about the space here. So x equals 25. So when we sell 25 units of chicken feed, poultry feed, then our cost will have met our revenue. Okay, so we're not losing any money. Once we sell 25, we've sold enough to take care of our cost. Okay, so now it says find the profit function. So again, profit function is revenue minus cost, right? So we want to take our revenue function, profit is how much we bring in, right, minus how much it costs. Colors aren't doing very well. So profit function is going to be our revenue function, which is 24x, minus our cost function, which was 20x plus 100. And again, always make sure when you're subtracting a function like that, an expression, always put it in parentheses, right? Because you have to distribute that negative. Okay. So our profit function is our revenue function minus our cost function. So if we solve that, we're going to distribute our negative. So we get 24x minus 20x minus 100. I had more students miss that minus 100 on these types of problems than anything else. If we simplify that, we get 4x minus 100. So our profit equation is 4x minus 100. So now we want to find out, now we can answer questions about profit to find out how much money we're going to make. So what is the profit? What is the profit if 100 units are sold? So we're going to find out how much money we're going to actually make and get to keep when we sell 100 units. And we know we're going to make a profit, right? Because we set up here that our break-even quantity is 25. So we know once we sell more than 25 units, we're making money, right? Because we break even at 25. So we expect a profit if we make 100, if we sell 100. So let's find out what that is. So we want to find P of 100. So 24 times 100. Oh, I'm sorry. Oh, I messed up there. We want to use our profit function, which is right here, right? So 4 times 100 minus 100 equals 400 minus 100 equals $300. So if we sell 100 units, we actually make a profit. We get to keep $300. Okay? Now, let's look at it a different way. So here we were given units and wanted to find out profit. Let's look at how many units must we sell to produce a profit of $9,000. So now we know we're going to make a profit once we sell 25 units, but but we need to make $9,000. So let's find out how many units we have to sell in order to make that happen. So this is the Y value, right, of our profit equation. So we're going to say we need a profit of 9,000. So we're going to solve 4x minus 100 to find out what that x value needs to be. So we add 100. So we get 9100 equals 4x. Divide by 4. And we get x equals 2275. So if we need to make $9,000, so let's say we have to pay rent or have to pay something, we need $9,000, we have to sell 2,275 units. Okay? So we've gone over a lot here. So we've talked about cost. So again, cost refers to how much it costs a manufacturer or a supplier to make your product, right? Because it always costs money to produce items before you sell them. And then revenue is how much you bring in selling it, right? So just quantity times price, how much money you bring in when you sell your product. And then you break even when the amount of money you brought in equals how much it costs you to make it, right? So that's the break-even point. And then anything above that, if you keep selling past your break-even point, you make a profit, right? And profit is actually how much you brought in minus how much it cost you to make. Okay? So now this next worksheet here is a try on your own. So I'm going to stop the video here in a second, and I'm going to post the answers to this on a PDF that I want you all to try, because I want you to try this on your own first. But a few little hints here. So so it's just like what we just went through with the poultry feed. They're giving you the cost equation. Okay, so you don't have to write it. You will have to write some cost equations as homework, but for this problem, they're giving you the cost. They're giving you that she charges $1.50 a taco. So again, when we're told what it costs to buy something, that is actually the price. So that is little p price. So now I want you to answer these questions. So what is the marginal cost? So again, refer to the cost function for that. What is the fixed cost? Refer to the cost function. What is her revenue equation? So you want to produce R times X as an equation. What is her break-even quantity? So again, that's going to be when the revenue equals cost. Find the profit function. So again, this is going to be revenue minus cost. This is revenue equals cost. Again, just a little review there. So break even is when revenue equals cost. Profit is revenue minus cost. And then just to answer a couple questions. So what is the profit if she sells 920 tacos? How many must be sold to produce a profit of $90? And then this is a little bit of a thinker question. If she sells 60 tacos a day, how long will it take her to start making a profit? Okay? So again, you might want to think about your break-even quantity and then 60 tacos a day. So anyway, do the best you can on that. But I want you to work on this worksheet on your own, or you can talk to your neighbor if you need to. But try to work it all out before you look at the answers that will be posted on LMS in the file section. And actually, yeah. I'm gonna post these as the last page of the completed notes. Okay, so you'll see the completed notes file section on LMS, and these will be completed there. But again, I want you to complete it first, and then check that. So anyway, have a good day, and good luck with this, and I will see you guys on Thursday. Great, thank you.